Hi there, I hope you're doing well. We're going to talk about electrons again in this one and how they're arranged in the atom. So if this rock tumbled over, it would be at a lower height when it's on over. It would have less energy output. So we're going to talk about energy levels and stability of atoms and the electrons in those atoms in this section. So there's 3 rules when we write electron configurations of elements. And they're important, and this section is important as well. So we're going to write where the electrons are in those various orbital shapes I showed to you, and that's called this electron configuration. So this is definitely on quizzes and tests, so we need to know how to do this. There's 3 rules. There's the Aufbau principle, the Pauli exclusion principle, and Hund's rule, and they all are used when we do configurations about where those electrons are living in the atom. So Aufbau rule says that electrons want to go in the lowest energy first because that's more stable, and then they want to fill up higher and higher as you go on. So electrons are going to always start low, and you're going to add some here, some here, some here. They're going to go this direction. So we have to follow that rule when we decide where to put electrons and where they live in real life. So we're going to use the Aufbau principle for that. And then we have to say that the Pauli exclusion principle says that if you're using the same orbital like a S or a P, the electrons have to live in there, and they have to both spin in opposite directions to make the atom stable. So that's called the Pauli exclusion principle. The last one says that states that electrons occupy orbitals of the same energy in a way that makes the number of electrons with the same spin direction as large as possible. So that may kind of go over your head for a minute. Let's use this in real life. So if you look here, hydrogen has 1 electron, and it goes in this lowest level, the first energy level, and there's 1 electron in the S. It's spinning one direction. Once we get to helium, it's element number 2. It's got to have 1 electron spinning one way and 1 the other way, because remember, S's will hold 2 electrons. Okay. The way we write these is H has 1 electron in the S. So the 1s, which is the lowest energy level, the S is the sphere shape, and there's 1 electron living there. In helium, we're saying there's 2 that live in that orbital. Okay. So this is the energy level, this is the orbital shape, and how many electrons are living in that shape. Lithium has 3 electrons. It's got the lowest energy level filled first. Then we have 1 more because lithium is element number 3, and it goes in the 2s. That's the next level up. And there's 1 electron spinning that way. So we have 2 electrons in the 1s. We have 1 electron in the 2s. Let's try a bigger one. Neon. This has the 1s filled with 2, the 2s filled with 2, then it's got 6 more left. We've got to deal with 2, 4, 6, 8, 10. There's 10 electrons in neon. The rest of them are filled in the px, the py, and the pz direction. So there's 6 in this 2p level. So there's 2 in the s, 2 in the 1s, 2 in the 2s, and there's 6 in this 2p level. Remember, these are the dumbbells, so there was one side of the dumbbell, the other side of the dumbbell. So, and they're all spinning in different directions to balance everything out. So that's how this is called the electron configuration, and we have to get used to writing these things. This is what we need to know. So the way you do that is you look at the element's atomic number, and then you fill in this order, like we were talking about, levels. And then these little numbers up here are the electrons. This number has to total up to your atomic number. So lithium is element number 3, so 2 plus 1 is 3. It works. So we always fill from the ground state. And let's try phosphorus. It's number 15. We have 15 electrons, and we can only put 2 electrons per orbital. And let's see if we can fill it in. So if you follow the chart of energy levels, you do 1s holds 2, 2s holds 2, that's 4, 2p can hold 6, that's 10. Then we're going to jump into the 3s level. 2 can fit there, 3 can fit in the p. So now we've accounted for all of the electrons in this element, in phosphorus. So all those numbers up top add up to the atomic number. So try some of those on the periodic table, see if you can get it. And then there's some elements that decide not to follow all these rules. So there are some exceptions, and I'll try not to burden you with too much of that. But some elements, they just feel more comfortable in lower energy levels if they violate some of the rules. And you know, there's always some people who have to violate the rules. And it just makes them more stable if they violate the rules. So elements always try to go for stability over anything else. So copper has one that is an exception to the rule. So let's see how you do on this quiz. So what element is 1s2, 2s2, and 2p5? So if you grab your periodic table, 2 plus 2 is 4, plus 5 is 9. Look for element number 9 and see if you can find it. I'll give you a sec. Alright, here we go. That is element fluorine. It's element number 9. Let's try the next one. How would you write configuration for nitrogen? So go look up nitrogen, look at its number up top of its little square on the periodic table, and see if you can figure out how to write nitrogen. These are all basic elements that I could ask on quizzes and tests. So let's see. So if you got that one, you did it right. So it's element number 7. Last one. Why would some elements violate the rules? So some of this arrangement, the way it's got half filled, is more stable than some other things. So there are some exceptions to the rule, and I'll try not to ask very many questions about those ones. But just so you know, there are some elements still don't follow the rules. All right, it was great talking to you. Talk to you again soon. Bye-bye.